Hey, boys and girls, I'm reaching out to you because as I'm looking over your work in the Google form, I'm noticing that at least two of the questions are causing people some difficulty. And so I'm going to go back over some of the questions in here. Watch this video if I send it to you and go back and correct your work. I'm pretty sure I have the settings set so that you can go in and correct it, and I'll double check on that too. All right, so the first question, that at least for this one, maybe 20% are missing it. And remember, this is hard stuff, so I don't mind at all that you're missing it, but I do want you to go back and correct your work. All right, so it says calculate the speed. Nick, Steve, and I decided to go to NC State to visit Will. NC State is in Raleigh, North Carolina, and is approximately 150 miles from Charlotte. So right there, I see the distance. So what I'm going to do when I do this is I'm going to remember my formula. Speed equals distance divided by time, right? And now I can do this. Speed equals 150 miles because that is the distance that was in the problem. And then I'm going to go back over and find out what the time was. All right. And if it took us 3 hours to get there, at which speed did we drive? All right. So let's go back to our paper. It took us 3 hours. So we drove 150 miles in 3 hours, and I know that my formula is distance divided by time. So I'm going to turn this into a division problem. 150 divided by 3. I know I can't divide 3 into 1, so I can do 3 into 15, and that's 5. 3 times 5 is 15, and then bring my 0 down and add a 0 here. So now I know my speed. If I went 150 miles per hour, right? It's 150 miles. 50 miles per hour is the speed if I drove 150 miles and I did it in 3 hours. All right, so go back and check and make sure you have that answer correct. Let's go back and look at the next question. The next question says 4 types of data that can be shown on a line graph. Now, boys and girls, this is literally just going to your video and watching. It was in this video. Let's see. Watch this video to learn the basics about representing data on a line graph. Right? And I actually show you several different places.
Hi, boys and girls.
Here.
All right, so the next part of our lesson for today is to start talking a little bit about distance over plane.
All right, I'm talking to you about line graphs
amount of
here.
time.
I'm talking about quadrants.
We're just sort of playing around with
right?
Right?
All
a
right.
flat line means
this tells you why they're important.
Times.
Right, let's move
it
on
says
to the
once
next
you
one.
get good at reading
them, you can spot trends. Look,
years,
right there.
Right? And this
weather
is the
data.
change from the average temperature.
I'm
and
going to
it's
write down
showing
weather
how
data.
over time from 1960 all the way up to like 1990, right?
All right.
That
next,
the change from the average temperature
maybe clicking through a little bit to see what else
the
comes up.
Graphs.
Oh,
all right, this
there
one
we go.
shows
population data. I'm going to pause it and go back over to my paper and write down population data. So sometimes taking notes would be a good idea when you're watching videos and doing the assignments, especially when it's brand new things. All right, let's go back to the video and let's click through a little bit more, see what else comes up. Health data, there we go. So now I have 3 of the 4 kinds. And let's go back to the video and click in a little more, see if I can find another kind of data that's on a line graph. Health data. Business, good, to tell you how much money you made over time. So let's go back over here and put in business data. All right, there we go, everybody. All right, next. Let's go and see what the next thing is on here. All right, so 4 types of data that can be shown on a line graph right there in the video. All right, and let's come over here. In video 3, which 2 elements are needed to find the speed of an object? Now, we just did a formula where we calculated the speed. Look right there. Distance and time. So when you're doing the next question, you literally just have to look at the speed formula, and then you need to write distance and, oh, you can't see it, I'm sorry. Distance and time. All right. So question number 1, question number 2, question number 3, and now let's go look at question number 4. Question number 4 says, oh no, wait, that was, no, 1, 2, 3. Oh yeah. Oh no, wait a minute. What did I do wrong? Oh, wait a minute. This is question 1. This is question 2. This is question 3. All right, good. All right, now question number 4 says, oh, it's also still video 3. Which 2 tools are needed to calculate the speed of an object? So let's go back and look at the paper. If we're going to be needing to do distance and time for speed, right, then we're going to need to pick tools that will measure distance. What tool will measure and time? What tool will measure time? Clock? A watch? A stopwatch? Those would all be good choices if we're going to be slick and predict. And then for distance, I need like a ruler for measuring distance, or a measuring tape, or that little wheelie thing that we have at school. I almost call it a wheelie thing because I don't really know the right word for it. All right, or a yardstick, a meter stick. All right, so by be slick and predicting, I can help myself find the better answer. And now when we go back and look at this, all right, which 2 tools are needed to calculate the speed of an object? A thermometer, is that in my list? Thermometer? No, so it can't be right. All right, let's go back here. A graduated cylinder, is that in my list? No, because graduated cylinders are for measuring the volume of a liquid. All right, an online stopwatch and a meter stick. Let's check and see. Meter stick, stopwatch. I think maybe we have the right thing now. All right, and then we know it's not a thermometer because we already said no to thermometer. Now, in video 4, which type of line formed in Miss Godfrey's graph? All right, let's go back and look at that video. And we'll just skip to the end so we can see what kind of line it is.
Hi, boys and girls. We are
at 0, 5, a coordinate. I'm going to go over to, and see, look, let's pause right there. Now, do you know the name of that kind of line? If you play Connect 4, that might be a way that you might know it. If you watch the rest of the video where I tell you the kind of line it is, that would be a way that you might know it. All right, so let's watch what I say.
What kind of line? Do you know what that kind of line is called?
Look.
All right, let me go ahead and tell you to be sure that over here, the x-axis is a horizontal line. Now, we won't put that on our graph, but this kind of line is horizontal. And this kind of line is a diagonal.
All right, let's go back and look. Which kind of line formed? Go back and look. Well, here I can close that out because we're done with it. What kind of line did I form? Was it flat? Was it straight up? And now let's finish watching this video.
Now, when you see a diagonal form, then that lets you know that your speed is staying pretty constant. Now, Nick's instructions were to walk at a constant speed, but that's hard to do. And if I connect these, right, then you can see that I'm not making a perfect diagonal because whether Nick didn't stay the same speed or whether I captured the time incorrectly, we didn't get to make a perfect diagonal. But right here, look, we did. You see Nick stayed really constant and I captured the data beautifully right there. So we have a section where...
So now I don't know if I said this, but constant means the speed stays the same. And when I go back and look at the data from you guys, a lot of people said change, that the speed changes. So let's look at this question down here. This is where a lot of people messed up. When you have a diagonal line on a distance time graph, the speed in like half of you said changes. So let's go back to my little paper. for the next question, which was question 5, then what was that already? Oh, diagonal, right? That means the line was diagonal. And for number 6, many of you said that the speed changes when it's a diagonal. A diagonal means constant, and constant means stays the same. All right, and let's go take a look at the last question. When you walk in a straight line and try to keep your speed the same, in science, your speed is called, all right, constant is the answer for this one. So let's go back over to the paper because accelerating, if you remember from our last few weeks, acceleration is any change in velocity, which means any change in speed or any change in direction. When you have a constant speed on a line graph, you have a straight diagonal, and that means your speed stays the same, and the science word for that is called constant. All right, so boys and girls, I'm going to be coming back in to look at the information that came from your, here, put it up here like this, that came from your Google form. Well, you see my pasta over there, don't you? All right. And let's make it like this. One final shot of the paper so you can freeze the video and refer to it. I'll move that off of there. Right? All right, so go back and make sure that your answers are all correct. Thank you so much, guys. Love you. Remember, this is super, super tough stuff. And if you messed up, that's okay because that's what happens when you learn. When you're learning new things, you can make mistakes real easy. But I promise you in the next 3 weeks, you're going to be like rocking this stuff out. All right. Have a great day. Love you. And I mean it. And there we go.